Hello, our viewers, our lovely subscribers. Welcome back to the channel, Motormouth Uganda. I want to start by wishing you all a very happy new year. We started this channel last year, and we can safely say we have now entered the new year and hoping to see it grow. We thank those who have subscribed, those who give us comments and ideas on what we should discuss on this channel. Happy New Year to my brother Ivan.
Thank you. Happy New Year too.
Yes, thank you. Today, Ivan is going to tell us about batteries, right?
Yes.
Ordinary batteries, I presume.
Yes, ordinary automotive. There are so many batteries, but some are used in all sorts of electronics. Some are used in cars. So I'm going to concentrate on those that are used in cars.
Okay, and because of technology, even the batteries used in cars these days are more than the usual ones that we grew up used to. Now
Yes.
that we have hybrid cars and even people with ordinary cars who have tampered and added extra batteries for their music systems and all other contraptions, the fridge, the what.
Yeah, there are
So,
some cars that have come with start-stop systems, start-stop engine systems. So those ones tend to have extra batteries, usually under the driver's seat. Some people have gone ahead and bought electric cars. I see electric bodas as well. So we shall be discussing those batteries in another video soon. Yeah. Thank you very much for the brief introduction. Um, I welcome all our viewers back to Motormouth Uganda. Um, I think the last videos we recorded were last year. And I was actually freezing at that time, you remember? I was
yes.
in a cold place. Yeah, but now I've been back in Uganda for like 3 weeks. So yeah, as you can see, I'm not wearing warm clothing anymore. So I'm rather comfortable. Yeah. So today we are going to discuss automotive batteries. And as usual, when we come to these the technical subjects, I like to share. I like to share presentations.
Okay.
I don't know if you have the presentation that I have today. I don't know if you can see it now.
Yes, I can see it. Automotive batteries.
Yes.
I think the
So
American
automotive,
batteries.
yes, automotive batteries. Um, what we are going to discuss today, as I said, there are many types of automotive batteries. But we shall concentrate on automotive batteries just for today. Even for automotive batteries, there are different types. Like you mentioned earlier, there are some for hybrid cars, electric cars, and so on. Yeah. So the basic construction of a nominal 12-volt lead battery consists of 6 cells connected in series. Now, most cars worldwide operate on 12 volts electrical systems. Each cell produces about 2 volts and is housed in an individual compartment. So what you have is a battery which is made up of 6 cells. What you see in the battery that you see inside are 6 different compartments, each producing about 12 volts because of the materials, the chemistry that they are using, lead acid, which we are going to be discussing very soon. The active material is held in grids or baskets, which form the positive and negative plates. So for each cell, you have 2 plates or 2 electrodes, and in between them you have insulation. One electrode is positive, the other is negative. The separators are made from microporous plastic insulate, and it insulates these plates from each other, like I've just described. The grids, connecting strips, and the battery posts are made from a lead alloy. That's why they are called lead acid batteries. The electrolyte is usually sulfuric acid. For many years, this alloy was lead antimony, but it has now been largely replaced by lead calcium cells. That's why on some batteries now you find calcium cell. It doesn't mean calcium makes up the electrodes and the grid strips and the terminals. It means it is an alloy of lead that is made with calcium. So most of you are familiar with these batteries. They typically look like the example on the image. Like I said, you have a negative and a positive plate in some kind of a small bucket. And these, usually you have 6 of these buckets, but you have insulation between the positive and negative terminals. Now, each of those buckets makes up a cell of about 2 volts. It's actually 2.1 volts. That's why you end up with 12.6 volts when with a fully charged battery. But we shall say 2 volts. And these are connected up in series, in line, to support each other. That's why you end up getting 12 volts, because they are connected in series, in line, so that they support each other, and you get a total voltage of 12 volts. That's the nominal voltage, but with a good brand new battery, what you will see, open circuit measurement will be 12.6 volts. So what are the characteristics of these batteries? Or the rating. A particular battery, the characteristics of or the rating of a particular battery is determined mostly by how much current it can produce and for how long it can sustain this current. The rate at which a battery can produce current is determined by the speed of a chemical reaction. Um, just so you know, if you didn't know, a battery is like a chemistry, it's a laboratory. There are chemical reactions going on all the time. When it is charging, the chemical reaction goes one way. When it is discharging, when you're using the battery, the chemical reaction goes the other direction. So it is repeatable. So this is the speed of the chemical reaction is determined by, just a minute. Sorry about that. Let me share the slide again. Yeah, the characteristics or rating of a particular battery are determined by how much current it can produce and for how long it can sustain the current. The rate at which a battery can produce current is determined by the following: the surface area of the plates, the temperature, the electrolyte strength, and the current that is demanded by the system. So we go back to how these batteries are rated. The common rating options are 3, although personally I've noticed it's mostly 2 which are used. The first one is the rating by the ampere hour capacity. This describes the current that the battery is able to supply for a specific time. For example, a battery that is rated as 44 amp hours should be able, if fully charged, to supply 2.2 amps for 20 hours. So 2.2 times 20 will be equal to 44 ampere hours. And then if you consider the mathematics again, if it can supply 22 amps for 2 hours, it will come to the same capacity rating, or even 44 amps for 1 hour. or 88 amps for half an hour, and so on. And this is something that it should be able to do before it is discharged down from 12.6 volts to 10.5 volts. So when we are testing batteries, as I'll mention later, I'm in the business of testing batteries. We typically discharge lead acid batteries, 12-volt lead acid batteries to 10.5 volts. That's usually the cutoff voltage for stopping the test. So then there is the option of rating the battery based on reserve capacity. This is quoted as the time in minutes for which the battery will supply 25 amps at 25 degrees centigrade to a final voltage again of 10.5. It is used to give an indication of how long the battery could run the car if the charging system was not working. Those of you who have suffered the alternator failures, alternators are something that we are going to discuss in the next video. For those of you who have suffered alternator failures, you realize the vehicle does not stop immediately the alternator fails because the battery will support the electrical system on the car until it is discharged. So this rating, the reserve capacity rating, is used to give you an idea of how long it is going to, the battery can support the vehicle when the alternator stops working or when the alternator isn't working, when the charging system is not working. So typically a 44 amp hour battery should have a reserve capacity of about 60 minutes. And then there is a cold cranking amps. This is usually what you will see indicated on the battery when you are purchasing it. This and the AH rating are usually what you will see indicated. It's not common to see the RC rating. So the CCA rating indicates the performance at high current output and at low temperature. A typical value of 170 amp means that the battery will supply this current for 1 minute at a temperature of 18 degrees centigrade, at which point the voltage will fall to 8.4 volts. Those are British standards. There are other ways of determining the CCA. There are other standards of doing this, but they all generally follow a similar protocol. It is the numbers that may change, the numbers used for the test. Please note that a heavy-duty battery will have the same ampere hour rating as the standard duty counterpart. Most of the batteries we buy are standard duty, but where you see a battery labeled heavy duty, it is likely having the same ampere hour rating, but it will have a higher CCA and RC rating because that means it can take the abuse a little bit better, but it may not last longer because the AH rating is the same. So if you use more current per second, you have it discharged faster, but it will be able to withstand the load, the loading abuse better. I don't know if you get what I'm trying to describe. Yeah, so when we come to maintenance of an automotive battery, the ordinary automotive battery requires very little attention other than cleaning corrosion from the terminals using hot water. I don't know, Alan, if you've seen the byproducts of corrosion on a battery terminal. Usually it's some kind of a white powder. A lot of people think it is chemicals spilled on there, but it's mostly to do with the materials used in the wiring of the vehicle, because the battery posts are usually steel or copper, and then the battery posts themselves, the battery terminals are lead. So that difference in in the metal compound is what usually creates that white corrosion. So you can clean that corrosion using water, and then um, smear it with petroleum jelly or Vaseline, not ordinary grease, to prevent that corrosion from continuing. And the top of the battery should be clean and dry. If it is wet or if there is some material, could be whatever chemical, could be water, could be acid, could be any material, it can create conduction of electricity between the two poles, the negative and the positive, and lead to flat batteries. That's why it is important to keep the top of the battery dry and clean. If not sealed, cells should be topped up with distilled water, at least 3 millimeters above the plates, because for a wet battery, the ones that normally have cups, usually there are 6 cups because each cell has 1 cup for you to fill up the electrolyte, which is usually distilled water mixed with the sulfuric acid. So when you're topping up, you're normally topping up with the distilled water. So this distilled water should rise at least 3 millimeters above the plates. If it is below, you are losing capacity of the battery because those plates are supposed to be covered for you to get the full capacity of the battery. Remember, this is the battery operates through chemical reaction. So if there is part of the plate that has not been covered by the electrolyte, you are already losing capacity because there is no current being flowing in the dry portion of the plates. So the battery should also be securely clamped in position on the vehicle so that it doesn't uh, flop around when you hit potholes and all that. And we have a lot of those when you go over humps or when you are driving on a rough road. And that's again because vibration kills batteries, as we shall see. If you have a bad suspension, you are likely to have batteries failing very early because the the plates that make up the plates in the battery are lead. And if it vibrates a lot, pieces of that lead keep falling off to the bottom of the battery. And every piece of lead that's falling off the plates is loss of capacity. So if you have a lot of vibration and the battery is not held securely clamped in position on the vehicle, don't be surprised if you are losing batteries quickly, if your batteries are getting tired very quickly. Then the state of charge of a lead acid battery is very important. And in general, it is not advisable to allow the state of charge to fall below 70% for long periods, as the sulfate on the plates can harden, turn into amorphous sulfate, and it makes the recharging difficult. In short, you lose capacity whenever your battery suffers from sulfation, what we are discussing now. If a battery is to be stored for a long period, that is more than a few weeks, then it must be recharged every so often. Charge it to full, store it. This way, you prevent it from becoming sulfated, because once a battery becomes sulfated, you lose capacity. And many times it is not easy to recover, for a battery to recover from sulfation, even in a relatively new battery. We try to salvage them. When we are testing them, we are able to recover some, we are not able to recover others. So it depends on how bad the sulfation got before we get our hands on the battery. It is something that a battery can recover from, but it needs to be tackled early. And in any case, the cause of sulfation is loss of charge. So make sure your battery, the state of charge of your battery does not fall below 70%. You may not be able to know when it is, what capacity your battery has left in it, but the safest way of ensuring that you are at 100% state of charge is to always give your battery enough time to recover. Once you start the car, you are discharging the battery. And the ignition starter motor takes a lot of current, takes a lot of power. That's why they use lead acid batteries, because they can take abuse. They can discharge very high current in a very short period to get the car to start. The problem with lead acid battery chemistry is that the battery takes a while to charge up, especially toward the end. So if it discharges, if it was at 100, you use it to start a car, you use 20% of the charge capacity, you drive a short distance, maybe a minute or 2 minutes, stop the car, come back, start it again, use another 20% of the charge. If you keep doing that several times, you will notice the battery stops being able to start the car. But after you discharge the battery, it is probably going to take hours. If you discharge it to 20% or 15%, I don't even want to imagine you doing that. But if you did, it would take you several hours to charge the battery, because the chemistry of the lead acid battery is like that. It charges, it is very sluggish in charging, but very happy to give you back that power very quickly when you want it. That's a peculiarity with it. And the reason why lead acid batteries are used a lot in cars is because they can give you that high current when you need it. But now their weakness is they take very long to charge. So make sure when you start the vehicle, take at least several minutes, 10 minutes, 15 minutes before you shut down the engine. If possible, drive it for about 30 minutes to 1 hour is a good. Yeah, so you notice that if you drive the vehicle regularly and for long periods, usually you don't get a lot of battery issues. The images you are seeing now is a sample of battery chargers. The one you see on the left is a typical home charger, and the one you see on the right is an example of a commercial charger. Repair garages should have the latter, the commercial type. Most of them also work as jumpstart kits. That is the commercial one, not the home one. The commercial ones also are also able to jump cars. For guys who are for garages who fix electrical issues on cars, who do troubleshooting on electrical systems of cars, because you need to do most of the troubleshooting with the key in the on position, meaning the vehicle will be taking power from the battery. It is a good idea to have the commercial type of charger on the vehicle as you are working, so that by the time you are done with the repairs or your investigations, the battery is good enough to start and you don't need to jump the car. Yeah, so here are some symptoms of when you have issues with the battery. If you consistently have a low state of charge, it means you are having it's possible that you are having a fault with the charging system. You may be having an unwanted drain on the battery. An example I gave is a dirty top, which is conducting electricity between the terminals. So you are losing capacity all the time, or you have a component on the vehicle that even when you switch off, like even when you turn the key in the off position, it keeps draining the battery. The electrolyte may be diluted, and then you may have an incorrect battery for the application. You may have a smaller battery than should be on the vehicle. Or if the battery is correct, but like you mentioned earlier, Alan, for people who put larger music systems on the vehicle, usually they should add capacity, battery capacity on the vehicle, because a battery that once used to serve the vehicle, if you put extra loads, electrical loads on the vehicle, this battery may no longer be able to cope. So it could explain your low state of charge. And then if you have you consistently have low capacity, it means you are using this battery in a low state of charge, or the corroded terminals are taking away capacity, like I mentioned. You may have impurities in the electrolyte. The battery may be suffering from sulfation. And then again, the battery could just be old, as in it is tired. Everything gets tired. Even a good battery eventually gets tired, gets old and tired. So if you notice excessive gassing and the battery getting hot, you may be overcharging the battery. Maybe there's something wrong with your alternator or your charger, or the battery may be positioned too near an exhaust component in the engine bay, or something else that is making the battery too warm. And then if you have a short-circuited cell, how do you know you have a short-circuited cell? A battery that should be an open circuit, when you test it with a multimeter, that should read 12 volts when fully charged, reads 8 volts, 7, 10, 9. That one probably has a short-circuited cell. So that will result from damaged plates and insulators internal in the battery, and a buildup of active material in the sediment trap. Like I said earlier, as the battery is getting used and it is getting shaken around, you are losing part of the lead plates, the material that makes up the plates, to the bottom. It flakes off and falls to the bottom of the battery. Now, once it gets there, remember lead is a conductor of current. So if that active material accumulates in the sediment trap and then rises and it starts touching the plates, it touches the negative and positive. That right there is a short circuit, internal short circuit in the battery. If you notice that the battery is open circuited, it could be due to a broken strap, excessive sulfation, very low electrolyte. And if you notice that the service life you are getting out of your batteries is shorter than expected, then it could be due to excessive temperatures. Maybe the batteries have too low a capacity for the application you are using them, like I mentioned earlier, music systems and stuff added onto the vehicle. You are having excessive vibration, which is ruining your batteries, like I've been saying. You may have a contaminated electrolyte, long periods of not having the battery used, and even overcharging can ruin the battery. I hinted earlier that we test batteries at PCAE, which is Process Control and Automation Engineers, which is my day job. We test ordinary lead acid automotive batteries, the ones you are used to seeing on the vehicle, but we also test hybrid vehicle batteries, which I'm going to discuss in some videos soon. Hybrid vehicle batteries have different chemistries. They don't use lead acid. We shall discuss the chemistries when we get to them. Same for electric cars, forklifts and motorcycle batteries. A lot of those use lithium ion chemistry. Solar system storage batteries, some of them are lead acid, some are lithium ion. I've even started seeing the newer ones are sodium. Then inverter system storage batteries, quite similar to solar system storage batteries. And generally, any commercial battery, if you need to test it, especially for capacity, you can inbox me, you can contact me, and we handle that for you. Yeah. Thank you very much, Alan. I don't know if you have any comments or questions. I know it was a rather long presentation. We have about 7 minutes. I don't know if you have any comments or questions about batteries.
I don't think I have many comments since it was more of a chemistry lesson with a lot of,
Yeah,
and chemistry was a hard one for me. But I am glad that you've talked about this issue of batteries. It is something that people usually don't pay much attention to until the car cannot start, or when they go somewhere and forget to switch off the lights and the battery runs out. So most people don't even think about where the battery is facing, which terminal is which one,
until it
only
fails.
until it, yes. And
Mm.
yet I have seen a lot of advertisements on which batteries to buy, but somehow it is still not catching people's attention. But
Yes,
on the channel, we talk about everything basically. So today has been batteries.
yes. Thank you. Additionally, people tend to buy, there's always a big argument which brand is better, which type of batteries is better. There are things I've not talked about, like AGM batteries. AGM still use the electrolyte is the same. It's still a lead acid battery, only that the electrolyte is a gel. That's why they call it the G in AGM battery stands for gel. Then I've not really seen lithium batteries being used in normal automotive batteries. I see lithium ion batteries and cadmium ones used for hybrid, and we shall discuss those another day. On lorries, sometimes you get um, on commercial vehicles, not only lorries, on commercial vehicles, they use 24-volt system. Even there are some cars which use 24-volt systems. You need to be careful. Some Land Cruisers, for example, use 24-volt systems. Those will usually, you normally get two batteries, 12 volts in series. Or sometimes you get one battery. It's not common to get one battery of 24 volts, except in solar and inverter systems. But for automotive, usually they use, even on lorries, yeah, they tend to use 12-volt batteries, but line them up in series. Buses, the same. Yeah, I think some use one big 24-volt battery. Yeah, but the chemistry is quite the same, and it has been like that for many years, more than a century. You'll wonder why the chemistry, the technology is not changing. It's because of the reliability of that chemistry. The downside, like I said, the upside is that chemistry can give you a lot of current, more than what the other chemistries can give you. And this is what you require when you are starting the engine. When you are starting the engine, that's when you take the highest current from a battery. Some systems can even draw 400, 300 amps. That's a lot of electricity. You may not be able to get it from other battery chemistries. The downside, though, is it takes longer than other chemistries to charge up. And again, because it has been around for a long time, it is now cheap. Then there are other discussions about the environment, dispose of the batteries. In this video, we may not cover that, but it also has issues. But the good thing is most of at least the local manufacturers that we have for these batteries, they are happy to receive old batteries. They recycle them. They extract the lead and whatever other materials and recycle them and get new batteries. Even batteries for, like the batteries we shall talk about for hybrid cars and electric cars. Yeah, a lot of investment is now going into reusing the materials. So it's not they are not always just dumped. In fact, they may be the new gold in the future with regards to materials that make these batteries. Yeah, thank you very much, Alan,
You're
for
welcome.
for your time. Our viewers, the next video we shall be uploading will be about alternators. That is now the other side of the battery. Because these batteries, they get discharged when you use them, they need to be charged up. So we shall be discussing the alternators next. Thank you.